Hello everyone. I just quickly wanted to show some of the improvements that we made in the 2017 release of our DFTB implementation in the ADF modeling suite. So two of the things that we think will be very useful for people working with organic crystals are that we now support DFTB3 also for periodic systems. That was not yet the case in last year's version. Also, we have greatly improved the performance of the D3 dispersion correction with Becker-Johnson damping. If you ever used this feature in last year's release, you will know that it was kind of slow for periodic systems. So we hope that this is much more usable now. As the example system for this video, I'm going to use one of the compounds from the latest round of the crystal structure prediction method blind test that is held every couple of years by the people from the Cambridge Crystallographic Data Center. And I'm not going to do anything really close to a crystal structure prediction here. I'm just going to take the experimentally obtained geometry and then optimize it in DFTB using the DFTB3 Hamiltonian and the D3 dispersion correction with Becker-Johnson damping. And the specific compound that I'm going for is the system that's called 26 here in this paper. And I'm just using that really because it's the largest one that they have. And I already have the experimental geometry of this crystal, which I will load into ADF input, and then we will optimize it using DFTB3 with the D3-BJ dispersion correction. So let me import the crystal. Let me make this full screen. So this is it. This is the unit cell. I don't know how many atoms this are. It's 124 24 atoms in the unit cell. So not crazy big, but already fairly big, so that DFT would be quite. It would take quite a while. So I'll switch to DFTB and we'll do a geometry optimization. We'll also optimize the lattice, of course. I'll increase the maximum number of iterations here because the default is 50, but for lattice optimizations they tend to require more steps, so I don't want it to abort halfway through the optimization. So I will just set it to something unreasonably large, like 1,000. Then we'll switch to the DFTB3 Hamiltonian with the D3-BJ dispersion correction, and as the parameters we will use the latest version of the 3OB set from the Elsner group. And I believe that should be it. Let me save this job as geometry optimization, and then I can close ADF input, and I will run it from ADF jobs. So now the calculation is running, and because we do a lattice optimization, we actually have more than one SEC cycle per geometry optimization step, because the lattice gradients are done numerically. And we've also improved the performance of the numerical lattice gradients over last year's version. So we now reuse more information between these geometries that are only slightly different, which reduces the number of SEC cycle iterations for the slightly displaced geometries. And we should be able to view the optimization while it's running in ADF Movie already. So there is our crystal. And let me add the graph for the energy. Oh, we don't have any data yet. I'm gonna have to wait for a while. There is the first point. So this should build up over time now as the calculation is running in the background. It's running on my workstation machine. So it might take a while. It's not a super fast machine, but I think I will just keep it running. And then in the video we will fast forward time, and I will be back when the optimization is complete. Okay, so the optimization just finished, and this is the result. I think not much changed actually, because we already started with the experimental geometry. So the DFTB3 geometry, of course, shouldn't be too different. That would be kind of surprising if the minima weren't close to each other. We can look at how it changed over the course of the simulation here. So the lattice vectors changed a bit, and overall it seems like it shrinks a bit. I think we can also visualize the unit cell volume actually. Cell volume. Yeah. So apparently for DFTB3 the unit cell wants to be a bit smaller than an experiment. Well, I hope you liked this video. If you have any questions about the new features in ADF 2017 or run into any problems with them, then please just contact us at support@scm.com. Thanks for watching.